Okay, so here we have a rectangular prism, and we know it's a rectangular prism because the base is a rectangle, and we know that it's a prism and it's 3D because it has length here, it has height here, and then if we flip it this way, we can see the width going backwards. So it's the length, width, and the height. And we're going to figure out how to find the surface area of this figure. Now the surface area is finding the area of all the surfaces and then adding them together. So if you look here, we have 1 surface, 2, 3, 4, then this green one is 5, and 6. So we have a total of 6 surfaces that we need to find the area for. And another way to think about surface area is if I wanted to wrap this box, we pretend it's a present, if I wanted to wrap it, how much wrapping paper would I need so that each surface was completely covered? So now what I've done is unfolded the rectangular prism. And if you look here, all you have to do is reconnect the shapes and we'll have our prism again. But when you lay out a figure, 3D figure flat like this, this is called the net. So this is the net of a rectangular prism. And this is helpful in really figuring out what the surface area is. So what I've done is go ahead and figure out what the 2 bases are. And so blue is going to be our base. So the blue is our first base, and the area of the base is length times width. The second blue here is our second base, and the area of this is the same, length times width. Now the 2 green ones are a different shape, and those are the width of the figure as well as the height. So to find the area of the green ones, we have width times height, and width times height over here. And then for the red ones, we have length, so how long it is, times the height. So to find the area of the red rectangles, we have length times height. Now, one way to find the surface area is to do all these calculations and add them together. But there is actually a formula that combines all of these to make it a little bit easier for us to plug in numbers and find the surface area. So the formula of finding the surface area of a rectangular prism, when we take all these formulas and combine them, is surface area, which we use an S to represent surface area, is 2 times length times the width plus 2 times the length times the height plus 2 times the width times the height. And the reason that there's a 2 in front of each combination of length, width, or height is because if you look up here, there's 2 for each formula. So there's 2 reds, 2 blues, and 2 greens. So now we know how to find the surface area, let's do a practice problem. So here's a rectangular prism that I've drawn, and the dimensions are labeled. So the length is 14 meters, the width is 6 meters, and the height is 8 meters. So I'm going to go ahead and plug in those numbers. Now it's really important when you're plugging in your numbers that you use the correct numbers for each width and height. So it might be helpful to label on your diagram what is the length, what is the width, and what is the height, so you don't get confused. So here I went ahead and evaluated the surface area of this rectangular prism. I plugged in all of my numbers, multiplied each together, and then multiplied each number by 2, added them up and got a total of 488 meters squared. Now make sure you note that it's squared, and the reason it's squared is because we're finding the surface area of this, and area is squared units. Okay, so now we're going to talk about finding the surface area of a cylinder. And just like we did with the prism, we're going to look at the net of a cylinder. So the net of the cylinder looks like this. We have a rectangle here and two circles that are the bases. So to find the surface area of a cylinder, we obviously need to find the area of this rectangle here, and then the area of your two circular bases. Now the only tricky thing that can get a little bit confusing is the area of this rectangle, because normally you want to just do length times width. But the actual length of this piece right here is 2 pi r. And the reason for that is, if you think about what a cylinder looks like, when you roll this piece of paper up to get it to look like this, the part that's rolled is actually the circumference of the circle. And that's why, to find the length of this part here, we need to actually find the circumference of the circle. So that's why you have this arrow here, just showing that this length is actually the circumference of this circle. So that would be our length here. And then we would simply multiply it by the height. And then to find the area of the base is an area of the circle, which is pi r squared. So that brings us to our formula for the surface area of a cylinder, which is surface area equals 2 pi r squared, and this is the area of the circular base pi r squared times 2, because there's 2 of them, plus the area of the lateral surface, which is circumference of the circle, 2 pi r, which is going to give us this length here, times the height, which is h. And you add those two up, and you will find the surface area. Okay, so here's an example of a cylinder, the net of a cylinder, and we need to find the surface area of it. So I have written up here our formula for finding the surface area, and now I'm going to plug in my values. So I have surface area equals 2 pi, and r is 4 squared, plus 2 pi, r is 4, and my height is 3. So now this equals 2 pi Now I go ahead and get 32 pi plus 24 pi, which equals 56 pi. And if I evaluate that, I'm going to round to the nearest tenth. I get 175.8 millimeters squared as my surface area. Okay, here are your on your own questions. For the first two, I would like you to make a net for each figure. So you have one prism and one cylinder. For the next two questions, I would like you to find the surface area of each cylinder, and you are given the measurements of the radius and the height. So the first cylinder has a radius of 1 meter and a height of 4, and the second cylinder has a radius of 2 millimeters and a height of 5 millimeters. And for the last two, you need to find the surface area of each prism, and the dimensions are given on each picture. Make sure you show all of your work.